Hello and welcome to this presentation of transformations in graphs of exponential functions. As we walk through this video, you will be able to stop and answer questions to kind of reinforce your understanding of the concept. But before we do that, reminders of what's coming up. Again, if you happen to be one of the people who emailed me over the weekend, I'm getting through those emails and revising grades. That is in process. Our next quiz will be Monday on February 3rd, and there will only be two topics on it. One will be transformations, and one will be solving exponential equations. So what we do today and what we do Wednesday, Thursday, Friday, those 3 days will be solving exponential equations. And then our unit test will be on Friday, February 7th. We agreed on that in our algebra meeting yesterday. So that's when you can expect the test on this unit. Everything on the quiz from yesterday plus everything on the quiz this upcoming Monday. All right, let's take a look what's going on today. So take a second, turn to your packet, page 22 in your packet. You should see something that looks like this. Now, when I put the packet together, I didn't look exactly at what the county expects us to do for transformations, and they don't expect us to do everything in this table. So we are going to cross out a few things. So take a look here. We're going to cross out the horizontal translations, the horizontal stretches and shrinks, and the reflection over the y-axis. So we're only left with three things. And we have really talked about some of these things throughout the unit. So I think that in combination with what we did with quadratics, I think will help you understand transformations on exponential functions. Okay, so let's talk about these things for a moment. When we're talking about vertical translations, that's going to be shifting the entire graph up or shifting the entire graph down, right? And what we see in the function is an addition, something added on the end that's going to shift the whole graph up. So in this example, that +1 on the end is going to shift the whole graph upwards 1 unit. Now, if you've got something that's subtracted on the end, like this minus k here, or this -6 here, that means we're going to shift the entire graph down. All right, so vertical translation is usually the easiest thing to recognize. That between that and a reflection, I guess, because you just have something tacked on the end of the function, either addition or subtraction. Now, if we're talking about reflection, y'all probably even know this without me saying, when you put a negative in front of the function, a negative is going to take that function and flip it upside down. So our initial graph that runs along the x-axis on the left and goes up on the right, that's going to flip upside down, and it's going to just be just like a mirror. Okay, and it's just going to, it's still going to run along the axis, but it's going to be below the axis, and then it's going to shoot down instead of shooting up. All right, so definitely when we see a negative out in front there, it's a reflection. And then the last thing is when we have some a value. That a value is going to stretch or shrink your parent graph, okay? So if that a value is larger than 1, it's going to stretch it. So that 3 value here is going to stretch your exponential function. And if it's less than 1, like this 2/3, it is going to shrink our exponential function. All right, so if a is less than 1. And we see that show up in the y-intercept. If there's no stretch or shrink, your y-intercept is going to be 1. But we often see an a value, like that is different than 1. So you probably know these things without us putting words to these things. So let's go ahead and move on. All right, let's take a look at these examples. And because some of these examples included things that we don't have to learn, you will find that some of them are slightly different than what you see in your packet. So go ahead and adjust those as we come upon them. Okay, so the first one is exactly the same. And what we're going to do here is describe what is going on with our parent function. So in this case, the parent function is going to be, and your parent function is always going to be y is equal to b to the x. Forget the a, forget any adders, forget any reflections. So in this case, our parent function is going to be g of x is equal to 4 to the x. Okay, this is our parent function. All right, now what does that plus 6 do? Well, that's going to shift our parent function. How many units? 6 units. In what direction? It's going to shift it up by 6 units. Okay, let's look at the second example. This one has been adjusted a little bit. All right, so what is our parent function? Our parent function here is going to be g of x is equal to just the b to the x part, 1/2 to the x power. Okay, and what has happened here? We have shifted this function 5 units down. All right, take a quick break. Oh, no. Let's go ahead and talk about these two. What is going on here? Well, if we're thinking about our parent function, it's just the b to the x part. Okay, so our parent function is going to be g of x is equal to 1/3 raised to the x power. Now, we're not shifting up or down here. We see we have an a multiplier, and so this is a vertical stretch. By a power of 8. All right, and for number 4, we have more than one transformations going on. We see actually want to stay. There we go. We see something going on the end and something going on the beginning. So let's start by identifying our parent function. And our parent function is the b to the x part, so g of x is equal to 3 raised to the x. And then what's going on with that -1? We are shifting the function 1 unit down. And what's going on with that 2? Well, we are taking the function and we are vertically stretching it. vertically stretching it by by a factor of 2. Okay, so again, remember that if this a value is greater than 1, we're going to stretch, and if it's less than 1, we're going to shrink. Okay, so let's look at these two now. These two have been adjusted. Notice that they have something we haven't talked about yet in examples. We see what's going on in front. That negative sign, okay? And so remember that that's going to indicate a reflection has happened. Let's first start with our parent function. Our parent function is going to be g of x is equal to 2 to the x. And then we've got two transformations. We've got that reflection over the x-axis. Okay, and we also have what's going on the end here. We are also shifting up 2 units. Okay, and the last one like this, our parent function. What do you think it is? Hopefully, you said g of x is equal to 4 raised to the x power. Now, this one has 3 transformations going on. Okay, do you see all 3 of them? Well, let's see what you came up with. First, we see a reflection over the x-axis. Okay, second, here we see a vertical stretch. It would have been good if we had a vertical shrink in here. By a factor of 3. And last, we have a shift up 5 units. All right, nice. All right, let's go here to the next part of the notes. How do you graph an exponential function with transformations? Okay, so we've done some graphing before, but we haven't done a lot with a lot of different transformations. We've done some with, actually we've done stuff with vertical stretching and reflections, but we have done very little with asymptotes. Okay, so let's go ahead and see what this looks like. Let's first, in this case, we're going to identify the parent function and the base of that parent function. Okay, and that parent function, the base is going to be the multiplier, what we multiply by every time, the b value, right? The second thing is we're going to identify the asymptote. We're going to sketch that asymptote of the given function. And the asymptote is going to be y equals k. What do we add or subtract on the end? And then we're going to create a table of values. And we're going to plot the points and connect them with a smooth curve. All right, let's take a look and give it a shot. All right, in this example, we are going to be graphing the function g of x is equal to 4 raised to the x minus 3. So our parent function is going to be g of x is equal to 4 to the x. Okay, so our multiplier is going to be 4. So you can use your graphing calculators here to fill in the table. And if you know what the y-intercept is here, you can start there, and then you could just multiply by 4 going up and divide by 4 going down. So let's actually, well, let's go ahead and put this in our calculators because it may be helpful for us. If you put 4 to the 0 in your calculator, you're going to get 1. And if you subtract 3, you're going to get -2. But again, you can put that whole thing in your calculator and use that to help you. And then 4 to the first power is 4 minus 3. It's going to be 1. And 4 squared is 16, minus 3 is 13. So 4 to the negative 1 is 1/4. Minus 3 is going to be negative 2.75. And 4 squared is going to be 1/16. Minus 3 is going to be minus 2 and 15/16. So I think that's going to be about negative 2.9. All right, and you can use your calculator to get those values. Now, notice you're not seeing that B value emerge here in the Y values because of this piece here. That asymptote is going to mess things up a little bit for us to recognize the B value. Now, we would be able to see it in the difference. Yeah. You would be able to see it in the difference between the Y values. You're not going to have to do that in here though, okay? So our asymptote is going to be Y equals -3. Our Y-intercept is going to be 0, -2. Is this growth or decay? Is our B value greater than 1? Our B value is greater than 1, so this is going to be a growth function. Transformations, we're going to take our parent function and shift it down 3 units. Let's go ahead and plot our points and sketch our curve. So at -2, we're at -2.9. At -1, we're at -2.75. At 0, we're at -2. At 1, we're at 1, and at 2, we're way up off the graph at 13. So this is only 6, so it'd be way up off the graph. Sketch your asymptote at Y equals -3. Okay, and then go ahead and sketch your smooth exponential curve. Okay, so it looks something like this. Our domain is going to be, remember we said if it's the entire function, it's always going to be -infinity to +infinity. Our range is going to start at our asymptote, so it's going to be -3, and we're going to go up from there, so we're going to go -3 to +infinity. Okay. All right, so that's how you graph an exponential function with some transformations. All right, next thing, if you wanted to try this one on your own, I would highly recommend it. There is some learning that happens when you graph by hand. It's just like when you are learning your multiplication tables, you first learn what it means to multiply, and then you learn the tables. Okay, so turn to this page in your packet, and again, I've made some adjustments based on what we actually have to cover. When we're talking about vertical shifts, we're going to take that f of x, right, and we're going to add or subtract k. All right, and so these are just examples, but it's asking you to do something slightly different. This is asking us to describe the translation of g of x as it relates to, and they're labeling their parent function here, f of x. So taking a look at number 1, I need this to be a little darker. If you take a look at number 1, you notice that g of x is 2 to the x plus 3, while our parent function is just 2 to the x. So if I want to describe g of x as it relates to f of x, I can see that all we did to f of x was add 3. So what I can do is say g of x is equal to f of x plus 3. Okay, and with this illustration here, we can see that g of x is here's our f of x function here, and g of x is just shifted everything up 3 units. Okay, so understanding this kind of notation is also very helpful. When we're looking at the next example to the right here, we can see that f of x, our parent function, is f of x is equal to 1/2 raised to the x, while g of x is 1/2 raised to the x minus 4. So all we did to f of x is we did this minus 4. So we can say that g of x is equal to f of x minus 4. Okay, so the new function is g of x. That comes first. And then what happened to f of x to make it g of x? All right, let's try another one. All right, cross out this because this illustration does not work anymore because we are not looking at horizontal transformations. But let's look at this one. Our parent function is f of x, and that is f of x equals 3 to the x. Our new transform function is g of x is equal to 3 of x plus 1. All right, and so what can we say is g of x? G of x is f of x. And what do we do to f of x? We added 1 here. All right, give number 4 a try. Can you handle number 4? Give that a shot. All right, you should have ended up here. G of x is equal to f of x minus 8. Always start with the new function. Oops. The new function is the old function plus or minus whatever happened there, okay? All right, let's look at these. Now, notice that the first one is exactly the same, but the graphs of 6 and 7 are not the same as what's on your page. So just kind of follow along here, and we're going to do the same idea here. We're going to start with g of x. G of x is equal to f of x plus or minus something. So let's look at the graph. Here's our g of x function. How does it relate to f of x? Well, it looks like we went how far down? 2 units down, so this would be minus 2. Okay, and we'll do the same thing for the next example. We know we're going to start with g of x. How does that relate to f of x? Well, here's our new function, right? And our old function has been brought down how far? Looks like 3 units. So we don't even have to know what the function is, okay? But we're going to come back to that in a second. All right. And then the last one we can see is, here's our new function. And here's our old function. So what happened here? Our old function went up 2 units. So g of x is equal to f of x plus 2 units. Okay, so now we're going to come back to each of these functions and notice we are given what f of x is. We're going to substitute that in where we see f of x. So all we're going to do, actually let's change the color here so that we see what's happening. This is going to replace f of x. So this is going to be 1/4 raised to the x. And the rest is going to stay the same. So g of x is equal to 1/4 raised to the x minus 2. Okay, next one, I'm going to go ahead and write out everything except f of x. And here we're going to take what is f of x and put that right here. And the last one, same thing. Here's g of x is equal to f of x plus 2, but since we know that f of x is 5 to the x, we can write it like that. G of x is equal to 5 to the x plus 2. Outstanding. All right, dilations, vertical dilations. This is going to be y is equal to a times f of x. Okay, and so we're looking for that multiplier, right? If a is larger than 1, we have a vertical stretch. And if a is less than 1 but larger than 0, we have a vertical shrink. Okay, so let's go ahead and do the same kind of thing as what we did before. Okay, and so we're going to relate g of x to f of x. So let's start by just writing g of x equals, okay? G of x equals. Now, what happened to f of x to make it into g of x? What happened there? Hopefully you see that we've got this 1/4 in front of it, right? And so this is going to be g of x is equal to 1/4 times f of x. And then the other example is very similar. G of x is equal to, what's going on there? Well, it looks like we've got something being multiplied by my f of x. So 2 times f of x. Excellent. All right, let's look at number 10 here. All right, so let's take number 10, and can we do the same thing with all of these? We're going to use the same parent function, and these should be pretty easy, right? Because the parent function is going to remain the same. All right, and these have been altered. Some of them, not all of them. All right, if it was not a vertical stretch, it has been altered. So keep an eye out for those changes. But let's go ahead and do this. We've got g of x is equal to, well, our parent function is 4 to the x, so this is f of x. So this is going to be f of x, right? So we've got 2/3 times f of x. Now, is that a vertical stretch or a vertical shrink? Well, in this case, a is less than 1, but greater than 0. So this is going to be a vertical shrink. Let's go on to B. For B, it's almost identical, except that the fraction is different, right? And so this is going to be the same thing. G of x is equal to, since our parent function is 4 to the x, this is going to be 6 over 7 times f of x. Now, is this a stretch or a shrink? Well, our a value is, again, between 0 and 1, so it's a vertical shrink. All right, for C, same thing. Here's our parent function. This is f of x, so g of x is equal to 3 times f of x. And our a value is 3 here, so that means that since a is greater than 1, this is a vertical stretch. And lastly, here's our parent function, f of x, so g of x is equal to 5 over 2 times f of x. And so what's going on? Let's see. A is that bigger than 1 or less than 1? This is bigger than 1. A is greater than 1. So we have a vertical stretch. All right, let's take a look. We're almost done. All right, the given graph is a dilation of the parent function. Let's see. Yeah, we're almost done. The given graph is a dilation of the parent function. Find the function. Use a graph to write the equation of the function. Okay, so we know that g of x is a vertical stretch or a shrink, and we want to find out how much is it a vertical stretch or shrink. So this can be a little bit tricky. What you're going to do is you're going to find two y values for the same x value, and you're going to put the to find your a value, you're going to take your g of x and put it over your f of x. Old over new. Okay, so if you're looking at what's going on in 11, I can look here at x equals 0, but I'm not quite sure what the y value is for g of x. So let's move on to y equals 1, and that looks like 1/2, but I'm not sure. So let's see if I can find a better alternative. Let's look at x equals 2. Oh, this looks good. My g of x y value is going to be 1. My f of x y value is going to be 4. So my a value here is going to be 1/4. So my new function, g of x, is equal to 1/4 times f of x. And then since I know f of x is 2 to the x, I can just say it's 1/4 times 2 raised to the x power. All right, last one like this. I don't know that you're going to need to do this for milestones, but I never know what's going to show up on the interim and the county final. So I just don't know. This function is g of x, and we want to find what f of x is and then use that to calculate. Now, I only have the one graph, right? I don't have both graphs, but I could find what the coordinate that corresponds to the x value of 1 is for f of x by just substituting 1 in right here for the exponent. So our output would be 3. So that's for f of x, though, right? And so to find our a value, I'm going to take the g of x y value and put it over the f of x y value. And in this case, my g of x is 4.5 for x equals 1. And my y value for f of x is going to be 3. Okay, and so I would use my calculator to simplify this. This is going to end up being 3 over 2. And so now I can write my function g of x is equal to 3/2 times f of x. And we know our f of x to be 3 raised to the x. So g of x is equal to 3/2 times 3 raised to the x. All right. Last little bit here, reflections. How do we recognize reflections? We're going to see negative in front of f of x. Okay. When we see a reflection in the x-axis. So for number 12, we've got two things going on. We've got what? A reflection and what? A vertical stretch. And notice that our parent function is 2 to the x, so we can say g of x is equal to negative 3 times f of x. So we just replace that 2 to the x with f of x. Okay. All right. Let's match these functions. All right. So let's cross out d because that's something we have not done. And let's cross off b because that's something we have not done. So let's look at what's going on with A and C. Notice that they both have a negative in front of them, which means that they're reflected. So they're both going to be going down, right? So we can cross off the exponential functions that are going to be going up. Now, since b is greater than 1, this is going to be a growth function that has been reflected. So remember that a growth function is going to look like this, right? But it's been reflected. Okay, and so we see that going on in option D. So this is going to match up with D. And so if I'm looking at C, I notice that B is going to be between 0 and 1, which means it's decay. So our decay function starts up high, comes along the x-axis, and then that's been reflected, right? And so we can see that happening here in A, graph A. All right, putting it all together. All right, let's, this has all the transformations that we've talked about. We're just going to take a second and all we're going to do here is we're going to take this 3 to the x and put it right here. And I'm going to ask that we describe in words also what all the transformations are. So let's first relate it to f of x to g of x. So we would say g of x is equal to, and we're going to take that 3 to the x and replace it with f of x. So we would have negative 1/2 times f of x minus 1. And that would be our g of x function. So what is going on here? We have 3 transformations. We've got a reflection over the x-axis. We've got a vertical shrink. Why is it a shrink? It's a shrink because that a value is less than 1. And then we also have shift down 1 unit. All right. And the last one, the last thing is going to be one just like this. So again, we can see that this is our parent function. So we're going to replace this piece here with f of x. So we would say g of x is equal to negative 4 times f of x minus 2. And what's happening here? Well, we see a reflection over the x-axis. We see a vertical stretch. By a factor of 4. And we have shifted down 2 units. All right, so hopefully this helps you understand transformations with exponential functions. There is a Google form in your Google Classroom to practice these, and I will see you tomorrow. Have a good day, guys, and see you then. Bye.